Today we are going to see superconducting materials. When certain materials are sufficiently cooled below low temperatures, their resistivity suddenly drops to zero and their conductivity becomes infinity. Such type of materials are called as superconductors or superconducting materials, and the phenomenon is said to be superconducting phenomenon. Some of the properties of superconductors are electrical resistivity, effect of magnetic field, effect of current, Meissner effect, isotope effect, and persistent current. Now we are going to see the electrical resistivity property of superconductors. When a superconductor is taken and its temperature versus resistivity graph is plotted. The superconducting material temperature is decreased, thereby its resistivity value will also be decreased. At one particular temperature called as critical temperature, the resistivity suddenly drops to zero. So superconducting materials has zero resistivity. Critical temperature is said to be the temperature below which the material behaves as superconductor and above which it behaves as a normal material. If the graph is plotted for a normal material, there will be some amount of resistivity present in the material. Now, effect of magnetic field or magnetic property of superconductors. When a superconductor is placed in a very large magnetic field, and if the temperature is reduced at one particular magnetic field, its superconducting property will be destroyed. The magnetic field required to destroy the superconducting property of the specimen is said to be the critical magnetic field. It is given by the formula Hc is equal to H naught 1 minus T square by Tc square, where H naught is the field required to destroy the superconducting property of the specimen at 0 Kelvin temperature. Hc is the magnetic field required to destroy the superconducting property of the specimen at T Kelvin, and Tc is the temperature required to destroy the superconducting property of the specimen, which is termed as critical temperature. Now, effect of current. Consider a superconducting wire. Let R be the radius of the wire. Let I amount of current is made to flow through the superconducting wire material. This applied current induces some magnetic field in it because of electromagnetic induction. This induced magnetic field will destroy the superconducting property of this superconducting wire. IC is equal to 2 pi R Hc, where IC is said to be the critical current and R be the radius of the wire, and HC is the critical magnetic field.